Let's discuss about container orchestration. So why do we need container orchestration? For example, we are running a production environment and we are having one pod which runs Nginx. Okay, and this container is able to serve 100 users. Your application becomes popular and you are adding 2 more containers to handle the load. And as your application grows, you might be adding a few more containers to this environment. So if it's a single container, it's very easy to manage, but when we are having multiple containers like this, managing them becomes very difficult. So with help of container orchestration, we can manage all these containers using a single interface. And so what does container orchestration do? It manages the life cycle of the containers. So what is a life cycle? A pod getting created, a pod getting terminated, a pod getting restarted. Everything comes under the pod life cycle, and this will be managed by a container orchestration tool. And for example, if we have a Nginx container and there is a database container, in order for them to talk with each other and in order for them to configure the usernames, passwords, everything can be done via the orchestration tool. Let's assume another scenario. For example, there is a host node 1 where your container is running. Due to some issues, the host goes down. What will happen? Your container will get out of focus and you will not be able to serve traffic to your clients. So in case of container orchestration, what happens is there will be a lot of nodes, at least a minimum of 2 to 3 nodes in a cluster, and everything will be managed by a container orchestration tool. So even if a pod is present in a container, and even if a pod is present in a node 1, if something happens to this and the entire node goes down, this orchestration tool will get the container and place it on another node. Now, even though the server node is down, without any human intervention, the pod is up on the node 2 and still the users will be able to serve their needs and access your application. So this is another use of the container orchestration tool. And with container orchestration, if there is a different containers and you're managing them individually, it is very difficult for them to monitor. But when you have this container orchestration tool, you can monitor them in a single user interface, and you can get the data about the CPU, the RAM, and the disk pressure, name it. Everything can be obtained via a single user interface. And what does this, the container orchestration is capable of doing all this, but what does it serve? What is the advantages of it? For example, if a node has one container, if this node goes down, this pod or container is going to be automatically placed into another host. So by this, we are achieving high availability. Alright, and for example, let's say that your application, you're running an Nginx application again, and to serve many users, we are having 3 pods. So using container orchestration, you can configure a load balancer to automatically transfer traffic to any one of the containers based on which is free. So for example, user 1 might hit container at the top, and the user 2 might hit the container at the bottom, and user 3 might hit the container at the center. So a lot of good things can happen with container orchestration. And for example, let's say that we are having a node 1 and node 2 and node 3. This is one single cluster. So what happens if there is a need to even scale up our application more than the hardware limit? With container orchestration, we can easily add another node to this cluster and expand it. Without orchestration, it's very difficult to add and remove the nodes. Even with container orchestration, sometimes it's a bit difficult to add and remove the nodes, an actual physical server to the cluster. But without container orchestration, it becomes even more difficult. So what are the available tools in the market which can perform container orchestration? The first one is Docker Swarm. I'm sure most of you are coming here from a Docker background. So Docker Swarm is another tool that we can use for container orchestration. So using this, we can manage the lifecycle of the applications and everything. So the second one and the most popular one is what we are here for, Kubernetes, or we call it K8s. So this is the most popular container orchestration tool, and this is the one which is highly demanded in the market. And we do have other container orchestration softwares like Mesos, which is set up by Apache, but it's very difficult to set up. So, and even when we're considering Docker Swarm and Kubernetes, most of them are opting for Kubernetes. Why is that? It is an open source, which means anyone can make the modifications that they want, and they can alter the applications to serve their needs. And it is a project that is highly ranked in GitHub. So there are a lot of contributors to it, there are a lot of bug fixes to it, and if you ask any questions, there are a lot of people to answer it as well. And it has cloud native support. So most of the cloud providers currently offer Kubernetes, be it AWS, Azure, GCP, IBM Cloud. Most of them offer this Kubernetes as a service as of now. And auto scaling is very much possible. So auto scaling is a major factor that keeps most of the web applications performing, and as the user count gets increased, their pod count can be increased, and as the user count gets decreased, we can keep terminating the pods in order to save resources. This is another feature of Kubernetes. Okay. And who developed this Kubernetes? That's again a popular company called Google. And how was it developed? Which programming language was used to develop Kubernetes? It is Go programming language. And as Kubernetes progressed, it made the deployment of application very easy, and using this we can manage the life cycle of the applications very easily. And when we are having multiple nodes and we are having pods spread across these nodes, there should be some communication between all these three nodes so that these pods can effectively communicate with each other. So this can be set up via Kubernetes very easily. Without Kubernetes, the networking part itself is a big struggle. If you have any further questions or suggestions for future videos, please leave them in the comments below. We value your feedback and look forward to hearing from you.